Now let's look at the behavior of the function and the derivative of the function. Okay, so again, if I start with a function y equal to f of x, right? Okay, at any point I can talk about its tangent line, and f prime of this point will be the slope of the tangent line, right? Okay, so you can see that if the tangent line has a positive slope, okay, that if it goes up, then the slope is positive. It goes down, then the slope is negative. That means the curve has a tendency that is moving up. Okay, and here, for example, we also have a tangent line with a positive slope. Here we have another tangent line with a slightly positive slope. Okay, so here we can see that if f prime is positive, then the curve would be increasing. Okay, on the other hand, if I'm looking at this point here, then the slope of the tangent line is negative here as well. Okay, so this tells you that the curve has a tendency going downwards, meaning the value is decreasing. Okay, so now we know that if f prime is negative, then f is decreasing. Okay, so let me give you an example. If I have f of x equals x squared, okay, this is a toy example, and we know that the square function looks like this, gives you a parabola. So f prime is equal to 2x, right? Then I know that f prime is positive on the interval where x is positive, right? So that will be here. And as you can see, for a positive value x, the function value is increasing. So we do have f is increasing on the positive real line. So the r represents the line of real numbers or real line, and the plus means I'm only looking at the positive part, meaning x is positive. Okay, similarly, f prime is negative. You can see 2 times any negative number is negative, are negative. So what does that mean? That means f is decreasing. This is a very ugly decreasing. Okay, negative. So this is where the function is decreasing. Okay, and you can use this to analyze much more complicated situations. For example, if I have let's look at another example. So let's say if I have what do I want? F of x equals x squared minus x minus 6, for example. Okay, then I can have, by straightforward computation, I have f prime equals 2x minus 1. Okay. by setting this equal to 0, I have x is equal to a half. Okay, so what do I want to do this? So basically what I want to do is then see that what happens when x is greater than this critical point, and what happens when x is smaller than this critical point, because now I know that this is 2 times x minus a half, right? This is my f prime. Okay, so I have f prime positive on the part where x is greater than a half. Okay, f prime be negative on x less than a half. Okay, so this tells me that this is where a half is. It tells me that f decreases before, because f prime negative, f decreases before a half, and it increases after a half, like that. Okay, it does not necessarily decrease this way. It could decrease this way, and does not necessarily increase that way. It could increase that way. Okay, but at least I know that before x reaches a half, the function decreases. After x reaches a half, the function increases. Okay, and because it's a polynomial, so I know roughly it looks like this. Okay, but that's a different story. So this tells me f increases there, and decrease over there. All right, so this is how you can use the sign of derivative function to know monotonicity of a function f. Okay, monotonicity meaning decreasing or increasing.